Hi friends, my name is Rashnil and today I'm going to talk about movie recommender system. As we know, recommendation system has become a kind of a integrated part of our life, whether it is Amazon, where when you go to buy something, you come up with so many options, which is provided based on your past research or past shopping pattern, or people who are similar to you based on what they bought. Uh, Amazon try to recommend you certain products, or even whenever it comes to Netflix, where it recommends a certain movies based on your past preferences. So recommendation system has become very important topic over the past few years, and it's a great area of research and study. So I was very curious to understand what is the rationale behind recommender system, and that made me to move into this direction and probably build a small mini recommendation system using movie lens data. uh, so let's talk about it. uh, so as I said, I mean the basic problem definition was to uh, build a basic recommendation system which could recommend movies to user based on their past rating behavior and based on the ratings received to the movie by other users. So my main motive was to understand the concept behind recommendation system, and as well as to try out the latest machine learning algorithms which are used in Spark, Apache Spark using Java, and also do some sort of analysis and build the basic recommendation model in R. So, as we know, recommendation systems. So, recommendation systems are basically categorized into three main categories, or the three approach are used in order to analyze and build a recommendation system. The first one is collaborative filtering. So, in the collaborative filtering, basically we collect and analyze information on users' behavior, his activities, or his past preferences, and then using all this information about this user, we we try to predict if there are other users with a similar kind of pattern who share a similar preferences, similar liking. And once we identify these people, then we try to see, okay, what uh, is being rated by other people and which movie is being rated by other people, and then based on that we predict and we recommend new movies to the current user. So the second option is the content-based filtering. So in the content-based filtering, we recommend items that are very similar to those that our user are liked in the past. So suppose I go and I really likes something related to science fiction movie, say, or action, for example, say Terminator. So Terminator falls into a genre, say action. So and the approach would be to find another movie in the same genre, uh, say Rambo, which is being really liked by people and is highly rated in the same genre. So that is kind of a best matching items approach for recommendations. These days, there is another approach which has come, which is hybrid, which is a combination of the collaborative and content-based filtering, and where you mix the concepts of both and try to give a more optimum uh, recommendation to the user. So these are the basically three techniques which are widely used in order to build a recommendation system. So as part of this project, there are various phases that I had to go through in order to finally reach to the stage which where I am right now. So the first stage was data preparation, data collection, and the cleaning. So I had to basically go to movie lens. So there is a grouplens.com from where I downloaded two set of files. One was a small data set of around 100K ratings, and another one was a big data set which was around 22 million ratings. So I had to download from there, and the data was in a CSV format, and it had to be uh, it had to be loaded into the R and the Java, and the genre was actually it was kind of a combo file where various fields were separated by comma, and the genre was separated by pipe in the same file. So that was a little bit challenging task. So I will probably just show you the file, uh, how what was the format of the file. uh, so if we go here, so yeah, so if you s- sorry, so if you see here, so the file was in the format like you have movie ID, you have rating, you have user ID, you have the title of the movie, and the genre was separated in pipe delimited. So the other fields were separated by comma, but the genre was separated by pipe. So I had to parse them and finally understand, finally bring them to a form which can be processed. So next one, once I had the data ready, I did a lot of visualization and exploration using R and NIME to understand how the data is distributed and what is the data and how the data looks like. So and then finally, once I understood the data, I started ahead with model selection, and which I did using R and Apache Spark. And then finally, I did the implementation and evaluation using R, and the similar thing I did using different machine learning algorithm in Apache Spark using Apache's Java machine learning libraries. So I'll talk about all this in this video uh, uh, next. So okay, so talking about the data set, so as I was telling you, I got this data set from GroupLens research. So this is the movielens.org, movielens. So this data was generated on January 29, 2016, and it has five ratings, and which are in the increment of zero point 0.5, and it contains ratings for around 2 million, close to 23 million actually, ratings from for 32,000 movies, and it was rated by around 247,000 users, and these ratings were captured between 1995 and 2016. So as I told you, the data was in CSV format, and it was around 600 MB. So I had to basically normalize this data, because if you see the levels are too many, if I try to predict, it will create a lot of computation, and also it will take a lot of resource utilization. So to bring that down, also, uh, if we talk in general terms, if a movie is rated very poor by most of the people, it doesn't make sense to incorporate it and in the recommendations. So in order to do that, I had to normalize the data, and I had to take the movies which are rated more above 3 and above, and use that for recommendation. So this is the initial analysis that I did on R. So as you see, the most of the movies in the first histogram, if you see on the left hand side, so these are the number of ratings received for each year. These are the number of ratings received for each rating category. So if you see the movies that are there are a lot of movies which are rated 4, and there are a lot of movies which are rated around between 3.5 2.5 to 3. And if you see, the distribution looks a little bit of kind of a left skewed, where the very few people have rated 1 and 2 for very few movies. So on the next uh, histogram, if you see the plot, so in this plot we are seeing like there are very few people who rate a lot of movies, and there are people who rarely rate any movies. So the initial, I think around, you can say, 100 people, they have rated most of the movies. So most of the people are very active, and they watch movies and they rate a lot, but there are very but the majority of the people, they give ratings to very few movies. Similarly, if you see the mean rating, so there are a lot of number of yeah. So as I was talking about the mean rating, if you see, so most of the movies have received around 4 and 3, and also around 2.5, and rest of the movies usually receive very less rating, or there are few movies who receive 5 and around 4.5. But as we see, the most of the movies have received, maximum number of the movies have received around 4. So similarly, the below visualization shows us like the number of users and the items, and the darker the items, if you see, they are rated above 4 and above around 5. So you can see that very few people have the similar trend that we saw in the other plots, that very few people, they rate movies really high, and other people, they rarely rate it that much. So these are the about the plots, and to visualize the data. And finally, after this, I also used NIME. In the NIME, I just wanted to do a kind of a nearest neighbor algorithm, and I wanted to see which are the nearest movies to a recommended movie based on the genre. So here if you see the flow, I have loaded the movie data and the rating data, and I filtered out columns which are not needed, which is timestamp. So I didn't use timestamp for this project. And then in the numeric filter, I have applied filter to take movies which are between 4 and 5, and then for those movies I have created a partition of training and test set, and finally applied k nearest neighbor algorithm to identify the nearest or the most similar movie for the users who have rated, for our users, and the movies that are rated more than 4 and 5. So coming to the implementation in R. So for implementing this in R, I have used recommender lab package. In this package, it provides various functions and methods which can be used to build a prediction model, and especially for recommendation system. So there are various steps that I'd follow as I mentioned here, and I had to basically normalize it. So if you see in the histogram, this is the normalized data, where where I have normalized it against the mean. So it's the mean was around, if you see in the previous graph, so there was the mean rating, so it was uh, around 3.5. So based on that, this is normalized. And then I did a couple of test to identify which algorithm needs to be used. So if you see here, these are the 4 algorithms I have tested. One is user-based collaborative filtering. Second one is popular items. Third one is random items, and the fourth one is single value decomposition. So if you see on the right hand side, there are two graphs. One is the ROC curve, and the second one is precision versus recall. So based on testing both of the all the 4 algorithms, if you see, the user-based collaborative filtering is the most appropriate algorithm, and it gives the maximum uh, prediction and with least error. So I then further decided to use this algorithm and to predict uh, to build the recommendation model. So I'll quickly take you to the recommendation to the R and show you how I've done that. So here, if you see, I've just imported the library. I've created a training and test set, and then I had to convert this into real matrix. So the matrix is of the form, uh, if you see here, so these U are the users and I is the item. So this is basically items are our movie in this case, and U are the users, and the cell values are basically the rating received for by each user against the movie. So in the K nearest neighbor, so for a user A, we try to find the nearest user with the similar rating pattern, and then based on that we try to get the average rating from other users, and based on those rating we see, okay, so if you see here, for user UA, we are trying to predict for item I1, it's 3.5 based on the user rating from user 3 and user 4 who are nearest to this user. So the average it turns out to be 3.5. So basically, this is how we calculate the ratings for all the movies, and then we try to recommend the best movie to this user. The same approaches have been applied here, and so this is the recommendation system. You see, I have used the cosine similarity to uh, check the similarity between the different movies, and I've used a user-based collaborative filtering. So this recommender, what you see here is the recommendation model, and once the recommendation model is built, so we try to predict the movies. So I've used the top n, so I'm using top 10 movies for all the users uh, based on collaborative filtering, and this creates a kind of a list for each user with top 10 movies. And then finally so here I had done a lot of function calculation to bring it to a normalized form, and then here is the main function which just from the prediction model that we created, it gives uh, the top 10 movies for that user. So if I try to run this, say for user 2, 2 is the user ID, recommended top list is the recommendation model that we have developed, and movies is the all movie along with title and movie ID, so that we get the title along with the movies. So if I run this, you'll see these are the 10 movies that are being recommended by our recommendation system for user 2. If I do it for say user 100, so these are the these are the movies recommended for that user uh, based on this approach that I just talked about. So this is how it has been implemented uh, in R. Okay, so once it is implemented in R, I also wanted to explore uh, the Apache Spark machine learning libraries. So the, the the initial approach that you see in the steps is almost same. So if you see, I've used all these normalization, loading the data, and training the data. Uh, the approach used in R is a little bit different than in Apache Spark. So in uh, in R, I actually used user-based collaborative filtering by comparing various other algorithms. But in Spark, I actually used they only have one collaborative filtering library, which is based on matrix factorization method using alternative least square method. So I've used that method to build the model and finally predict movies. So I had a couple of challenges in Apache Spark. There were many performance issues. So I'm still working on it, but it's working. The overall logic is working, and it's giving the top 10 movies, but the performance wise, it is a little bit slow. So that is still in progress. Um, so coming to the matrix factorization. So what is matrix factorization? So matrix factorization is basically the similar concept that I talked about, which I was showing you in R. So where you have a matrix form, which is a sparse matrix, it is like you have the rows are users and the columns are items, and the cells represents the rating received for each user item combination. So if you see, there are not every person rates all the movies, so that's why there are many cells which are missing, so it's sparse. So if we want to process this first matrix as it is, it will be really uh, time consuming, and it will be require a lot of resources, so it's not a good idea. So to process these kind of a matrix, matrix factorization is to divide these matrix into two different matrix, which is one is user to k, u to k. K is basically feature factors. So feature factor, what I mean in this case, and which user has rated to which movie from particular genre is from the first matrix. So this helps us to uh, combine or decompose the matrix into a smaller uh, uh, dimension, and it becomes really easy and for us to calculate this. So when I say user to item, so in my last um, table which has like Batman, Star Wars, Titanic, you can see this is the kind of a matrix form that I'm talking about. So where Bill, Jane, and Tom are the user, and Bill has rated Batman 3, uh, and he has also rated Star Wars 3, similarly like that. So in matrix factorization, we'd use this uh, divided matrix to calculate the possible recommendation for the user. So if you see here in the third uh, plot, uh, the ones which are marked in red in U is to K matrix, these are the user for a particular user. Sorry, for a particular user, which are the movies which are the movies he has rated, and they belong to which genre. Similarly, then we check for those genre, which which are the other movies that belong to that genre from the second matrix. And using the cross product of this first and the second matrix, we get a possible set of movies which falls into the genre that the user likes. So that is the actually concept behind matrix factorization used by Apache Spark. And uh, and uh, this is the least square method. So this is a little bit math, so I'll just talk about it on a higher level. So what you see here, y is equal to u is to v. So basically we are dividing y, our original matrix, into two different matrix, and u dash is like u transform. So what you saw here, k is to y, it is a transform matrix uh, for genre to item or genre to movie. So that is the form. And then what we do is, in alternate least square method, we try to fix one matrix, and then we see what is the error. So like first we try to get the estimate of say v matrix using u, and then we multiply u is to v and try to get the predicted value, and we see what is the error between predicted value and the original observed value. And then once and we keep on doing this unless we try to find the minimum least square error. So once we get the minimum error between the original matrix which user has rated and the matrix that we have built using our prediction model or using ALS, then we stop doing this alternating method, and we build the we then we use that model to predict movies. So I'll just show you a little bit of what I've done in Java using Spark libraries. So this is the basically the loader program. So you see here, these are the Apache Spark machine learning libraries. The majorly was the recommendation rating libraries. And so here I'm taking the path of the file. So if you see here, so I have two set of files. The one files which you see here, these are the bigger files which I've used for finally building the model. And the files under train dataset, these are the files that I have used to initially train the model and build a recommendation model. So uh, this is my the folder structure. So I am reading file. So movie data loader is basically the file which loads the data and runs uh, all the it calls all the other functions in the other files. The application files is just the Spark context. It initializes the Spark context, and the model training. So model training, okay, I'll just go here down. Okay, so this is the main function. So this is the main function. So in the main function, I'm choosing different rank functions. So these are so this machine learning library had a rank parameter and an iteration parameter, which you had to, and a regularization parameter. So in order to find the best optimum uh, uh, parameters, I had to actually use different ranks and different iterations to finally get to a model. So if you see here, so these are the different runs that I went through. So one is the rank, iteration, regularization. Regularization is I have kept 0.01, which was the recommended from Apache Spark, but the other two I varied from 10 and 20 iterations. So when I say iteration, iteration is is the same what I just discussed in alternative least square, where you fix one and solve for other, and then you fix the other one and solve for the first one. So how many iterations you want for this thing. So, and rank is basically the rank of the matrix that you need in the decomposed form. So, um, so I use these kind of these parameters to test it, test the model, and based on that, if you see from all the runs, the one with the RMSE rank 4 and iteration 20, that was the best model and it gave me the minimum mean square error. So I've used this matrix to build the model, and finally so so basically sorry so I've initialized the path here. I've created an object of movie data loader, and which initialize all the path to the constructor function. And then I'm loading this into Java RDD, Java pair RDD movie data. And similarly, I'm loading the training data to the rating RDD. And then I'm trying to call the function in my model training class to return the best parameters. So in the model training class, I am basically uh, partitioning the data here. So if you do see here random split, I'm splitting the data into two, and then for each data I'm running this model training. So here this model is getting trained using our different rank algorithms and rank value, and then I build the predicted RD prediction predicted already, and yeah, and then I calculate which the comparison between what is rated by this prediction algorithm and what we had in our data, and that gives us the mean square error. So mean square error is nothing but the error in observed and predicted and squaring that error. So in order to get rid of the negative values, and then we take the mean to get the mean square error, and this is returned to my main function, and then I use these parameters for my larger data set. So when I ran this for my larger data set, I I got a much better performance of 0.84, 84% of mean square error. So that was really nice. And after running all this uh, so I created a new user for whom I wanted to predict movies. I just gave just gave him a user ID 0 and took some 10 movies and gave random ratings. And then based on I added I had added this data to the original data for all the users and created my original created my uh, full uh, recommendation model in the model building. As I was talking about the model building class, so here I basically am training uh, with a larger and big data set, and I'm trying to predict the movies. So I have a recommended movie function which returns the movies, and it returns which are predicted and are rated higher than 3.5. So once I receive these ratings, I am just going through the where it is. Mhm. Yeah, so there are many operations that I perform that I created a new movie RDD with just the user ID and all the movies and see what our prediction model is predicting for those movies which are not rated by our user. So it gives us an RDD. Basically, RDD is basically a kind of, you can say, a kind of a data set which has predicted values of our user 0 and all the movies in the movie file and the predicted rating from using our model. So so when I call this recommended movie uh, recommended movies from model building, so it will basically uses the unrated movies from the user, and then it using our model. This is the model that we built initially. It predicts the rating for all these movies for this user, and then I just take the movies which are higher than 3.5 and then return it to our main function. So this metric factorization and ALS libraries in Java Spark, they use same collaborative filtering that I discussed before in R. So this is the same method, but it's more of a, you can say, code intensive. You need to understand the coding here. So once I get all the recommended movies, I just take the top 10 movies uh, which are rated high, and I'm just displaying it here. So if you see for our user, the 10 movies that are uh, that are predicted are here, and based on his rating for the other movies, and as well as from the people, from the other users and their ratings. And the ratings that you see in the end, these are the predicted rating from our model. So our model is predicting, okay, based on uh, for this user, the probable possible rating that he could give to this kind of this movie would be around 4.11. So this is how I have built the two recommendation model. There are many further work that needs to be done. So sorry. So I had data for uh, user tag, user comments as well, but I, due to the processing time and the time limit, I couldn't include that. So I'm planning to include that after today and maybe before the semester. And so that is my next goal. And the second one was, there were many pictures which were associated with each movies, so I'm planning to incorporate that too, and maybe build a kind of a web application on top of Apache Spark to show the movies along with their poster. So that kind of thing. So I have my code is actually both for R and Java Spark is on GitHub. So if you guys really want to maybe explore these libraries and these concepts, or maybe would like to work with me and collaborate, I'm open to that. So you can just go to my GitHub Rash Hub and recommender system. So all the Java code is here. So if you see the same which I was showing you, so these are my loader file. So so this is the recommendation system. If you want, you can go here for Java Spark, and for R you can go to my R data analysis repository, and here you'll see recommender. So this is the full file where I have done all the operations, and you can follow this, and you can also build a recommender for yourself. So you can see the path here, so you can just go through it, and if you feel like, you can add to it, or you can work with me, and if you want. So, and these are the references that I've used to build all these models, and the help that I used from all the different uh, resources. So thanks a lot for watching this video.